Hello, I'm Peter, and now I'm going to give you a demonstration of the feeder control system. So first, let's look at the setup, and let's move on. And here is the full view of the setup. It contains the power supply, the motor driver, linear motor, Arduino boards, and computers. First, let's move on to the power supply. Power supply is to provide 24 volts to the motor driver here through the wires, and this motor driver will generate high frequency pulse to the linear motor through these 4 wires because of it is a 2-phase motor. And now let's have a close look on the driver here, and you can see the driver should be given the power signals and direction signal to control moving clockwise or counterclockwise. The VCC is the signal voltage 5 volts, and EN is the emergency stop. So these 4 wires will be connected to the Arduino board here. This is the control signal output, and this is the constant 5 volt output. So now let's move on to the software parts here. Okay, first you'll click the Arduino, double click, and then this window will jump out, and just open the software, the code. Okay, and the code jumps out here. Okay, the first step is to click the upload the program into Arduino boards, and yep, you can see this is done uploading. Upload is done. Okay, so now let's move on to this is a serial monitor. This is actually a control panel. I will click, and this window will jump out. And first you just make sure that this COM3 here, the serial port COM3 is corresponding to your laptop setup here. This Arduino board, Arduino Uno COM3, to make sure that it is in SAM, so they have a communicate. Okay, when it's okay, so it will pop up. This is an instruction here, and I have set up some basic function here. W is to moving forward and backward 1 cycle. That is to suitable to meet our functions, and R is the reset function that can enable you to set up different speed and different moving distance. And B and F is the moving forward and backward function, so you can move a certain distance. So you just enter B20 that can move backward 20 millimeters. And another thing is, when it's running, if you find something happens and the motor will be damaged, you can just enter any buttons. So emergency stop will be called, so the motor driver will cut off the current to the motor, so there will not be any damage. And I have set up the default RPM for the motor is 300. That's under testing. and distance to move is 105 mm. That is to cover the whole powder beds. So if we need to change, we just enter Y. So let's enter Y. Okay, then comes up input RPM. So we just input this value, and this is the maximum value that I have tested to be function. So first let's try a smaller one, 150. Okay, then you input the distance you want to achieve. That is I say 100. Okay, 100. This I want to move. Okay, so the system will tell you that it's ready to start. Okay, then the first thing to start is to initiate to determine the initial position of the linear motor. So firstly you measure the gaps of the distance that you want to move to initial position. Then move on to the green, and this is backward, so just backward here, and I say this is 20, so just press 20 and enter. So let's see how it moves. Okay, now it has moved closer here, and if you want to move forward, it's the same thing. Just press 120 F20. You will press enter. Okay, I will press enter, and you can see here it moved forward 20 millimeters. Okay, so now let's move on to the initial position as close as possible to the motors. Okay, let's first try backward 20. Okay, it's very close. Then we try our W function to move the one circle. And this screen also shows some informations. And okay, so let's give the W command. Okay, and I will enter. Okay, you can see you can run one cycle forward and backward very smooth, and the linear motor will, even without mounting it will not move. Right. Okay, let's move on to the monitor. You can see the monitor shows it move forward 100 mm and then move backward 100 mm, and it takes 6.91 seconds to move one cycle, and then come to the end. So now if you want to change to another speed and distance, so just press the R, enter. So the whole setting will be reset, and this time I will choose the default setting. So I will enter N here, and press enter. It tells you to starts. Okay, this time let's try the W function one more time to see what will happen. Okay, so let's start. Enter. It is clear to see that it has first we accelerate a little distance, then move a high speed, and then decelerate in the end. That can make the feeder to spread the metal powder very smooth and will not spread out anywhere. So let's come to the results. Here we move 105 mm and it takes only 6.13 seconds to finish all the now. If something bad happens in the between, you can just enter any buttons to keep it stopped. So first, let's try to move another W. Okay. Oh, I will enter and okay, I will enter. It's moving right, so I just press any button and you can see the linear motor will stop immediately, and because the motor dropper cut off the current to the motor will not have any holding torque, so it can prevent any potential damages. And after the motor stop, if you want, you can just tune the initial position, say entering the maybe A50, and you press enter, they can still goes back to the initial position, right? So it is very convenient for you to tune the speed and RPM. Now let's move on to the source code for some important specification here. This is the pulse, the ports 8, 3 ports to output. Yeah, okay. And this is the pulse per revolution. It is 400 and it must be consistent with the driver here. The driver here. This is have a table, and so I choose 400 pulse per revolution. It means 400 steps to complete the one cycle. So and this is switch on the sideway, so you can just switch on and off accordingly. And this is the maximum current for the linear motor. It is 1.6 A, but since it is the lowest loading is very small, we just set 1 M for safety. Okay, now let's move on. This is the default setting, 300 RPM, and the distance is 105 mm. So this default setting can be changed when we tune the valve later in the real machine. And now I have demonstrated some basic functions of this control system. And this system has really very convenient control, and the linear motor can move smoothly so that the feeder can function well. And this system also has very convenient to assemble in the laser cutting machine, because it takes only a few commands. You can see only a few commands here to make it functional. So I hope that this control system can be embedded on the 3D printing system later. I hope that this will be really helpful for you, and thank you very much.